All right, welcome back. So begins our StatCrunch adventures in Math 321. StatCrunch adventures. All your support work is done. Well, lecture's done. I need to zoom out. Thank you. StatCrunch adventures. Let's take a look at chapter 8. I want to remind you what's going on in chapter 8. We were looking at sampling distributions. And we start off with 8.1 we were looking at the mean. 8.1, we were looking at the sample mean. And that was just the mean of the population. And the standard deviation was the standard deviation of the population divided by the square root of n. As a reminder, n is sample size. So, like, for example, the IQ test is our go-to because it's a nice, good standard deviation. It's got a mean of 100, standard deviation of 15. And I asked 50 groups of size 9 what their IQ is. So we can see when we do groups of size 9, we stick it in up there, we're going to have a mean that's the same as the population. Standard deviation is going to be the standard deviation of the population divided by the square root of the sample size, which in this case is the 9, not the 50. We had 9 people in each group, so that's the size of the samples. Which is 15 divided by 3, which is 5. These are some steps that you kind of have to do. When you're working on problems in that section. (8.2) has something similar. I'm getting rid of all that handwriting shit now. 8.2, our mean for the population was equal to p hat, which was x over n. That was called our point estimate. So this section is on proportions. And standard deviation of p is the square root of p hat times 1 minus p hat over n. And the requirements to use this, for this to be a normal distribution, and that's usable. N times p times 1 minus p needs to be greater than or equal to 10. And n needs to be less than or equal to 5% of the sample or the population. Give me a minute to get all that in.
learning from the midterm on, or is it gonna be everything?
Chapter 8 on.
Okay.
Well, really chapter 9 on. Chapter 9 uses info from 8 though. Nothing from chapter 7 or 4.
Then a water question.
10. I don't know if you consider that a lot. Anybody need this up longer? All right. Back page. Go look at some stuff in our homework. So this is problem number 6. Problem number 6 in 8.1. It says a simple random sample of size n equals 40. I'm gonna write that down, n equals 40. Is obtained from a population that is skewed left. So population is skewed left. With a mean of 84 and standard deviation of 5. Does the population need to be normally distributed for the sampling distribution of X to be approximately normally distributed? Why? What is the sampling distribution of X? So we got some options here. It says A, no, the central limit theorem states that regardless of the shape of the underlying population, the sampling distribution of X becomes approximately normal as the sample size n increases. That sentence is true. Then B says the central limit theorem states that only if the shape of the underlying population is normal or uniform. That's not true. It can be skewed left or skewed right. So that's false. Any underlying population. C, yes. The central limit theorem states that only for underlying populations that are normal is the shape of the sampling distribution normal. That's false. The central limit theorem was as n got large enough, every sampling distribution looks normal. And D says yes, it needs to be normal, which is also false. It states the sampling variability of non-normal population will increase. Doesn't say anything about that. A is what the central limit theorem says. Then it says, what is the sampling distribution of X? Now we know, we just got done saying the sampling distribution of X is approximately normal. So we're going to use that, and now we need to calculate the mean and the standard deviation. And it says round to 3 decimal places. So n was large enough, n is 40, that's large enough. So the mean of X is the same as the mean of the population, which is 84. The standard deviation is the standard deviation of the population divided by the square root of n, which is 84 divided by the square root of 5. Get out my handy dandy calculator. And I'm getting, there's no way that's, I guess that's true. Jesus. Wait a second. The standard deviation is 5. N is 40. There we go. That's, I'm like, that is way too fucking large. There we go. To 3 decimal places. This is 0.791. All right, so we'll throw that into our answers. I want to make sure everyone's had a chance to write down what they want to write down before I flash over. I had the mean was the same and standard deviation is 0.791. Oh, here's a good one. So I've got a simple random sample of size n equals 81 is obtained from a population that's skewed right. Mu is 86 and standard deviation is 36. It says describe the sampling distribution of X bar. And then it gives us a bunch of things to calculate. So for here, n is large enough. So we can use the normal calculator. We can treat it as a normal distribution. Our sampling distribution. We only need to make the slightest of edits. The mu of the sampling distribution is the same as the mu of normal, and the standard deviation of the sampling distribution is a little bit less. It's 36, which is our standard deviation for the population, divided by the square root of n. This is 36 over 9, which equals 4. And that's what we need for part B. B is the probability that X bar is greater than 92.4. C is the probability that X bar is less than 76. Oops. Less than 76.6. And D, what is the probability that 81 is less than X bar, which is less than 92? We've said this follows a normal distribution, so we can use stats calculators normal. With mean equals 86 and standard deviation equals 4. What we calculated, not the default information we were given. You guys ready to go look at it? So the distribution is approximately normal. Oh, we already found the mean standard deviation. I jumped ahead. It didn't say it up above, but I got 86 and 4. And now we need StatCrunch for these. Stats calculator is normal. We're gonna do 86 and 4. And now I just got to make sure I match my signs up and type in the right number. Greater than 92.4. It says round to 4 decimal places. That's 4 decimal places, and it looks like I got to round up. Now we need less than 76. Change it over to less than. Four decimal places, it looks like I got to round up again. So I'll write these values in on the paper. And this one's a between. So we got to come over here and click on between. Do 81 and 92. And the 4 decimal places, I finally don't need to round. 0.8275. All right, I'm going to save some of them for you. Let's take a look at 8.2. All right, number 2 says, let's describe the sample distribution of p hat. And p hat, we got, assume the size of the population is 25,000. Describe sampling distribution of p hat. And it says assume n, big N, is 25,000. They give us little n is 1,200. And p is 0.127. All right, so we have to test a couple things. If for it to be normal, we need n times p times 1 minus p to be greater than or equal to 10. And we need n to be less than 0.05 of big N. So let's plug in what we got. Is that greater than or equal to 10? I'm getting 150 and some change. 150 plus is definitely greater than or equal to 10. Now we need to check the other one. Oh. So is 1200 less than or equal to 0.05 of 25,000? And I get 1,250. 1,200 is less than 1,250. So we met both criteria. So it has a normal distribution. So it doesn't say it, but let's find, I don't think it says it, we'll find out in a second. Let's find, since it follows a normal distribution, we've got a mean and we've got a standard deviation. The mean is just p hat. So that is 0.127 here. The standard deviation is the square root of p times 1 minus p over n. Square root of 0.127 times 1 minus 0.127 divided by 1,200. I'm going to say square root parentheses 0.127 times, we'll do another parentheses, 1 minus 0.127. We end our first parentheses. And we divide by 1,200. And we end our second parentheses. And it says 9.612 times 10 to the negative 3, which is, we move the decimal left 3 times. That's our standard deviation. Any questions on that one? How many of you guys are doing these same problems right now? Anybody? There's nothing wrong if you are. I'm just curious if I need to wait. Is anyone even listening to me?
It's hard to do that because they're totally different, so.
It should be the same questions, just different numbers. So it's like, this is like view an example live. Okay. It's okay if you're not, that's perfectly fine. It's better if you're not, I mean, you're presumably paying attention.
That's why I stopped. I
Uh-huh.
couldn't keep up.
If I need to go slower, let me know. Cause I got one more example and then I'm tapping out for until our class starts. We'll be done with 8.2. All right, let's go back over to the problem, make sure I did answer everything. We said it was approximately normal. Look at that, two of them say that. A says approximately normal and C says approximately normal. They both say N is less than 5% of big N. A says N times P times 1 minus P is less than 10. And the other one says N times P times 1 minus P is greater than or equal to 10. That's the one we want. Oh, they did want them. Conveniently, we already calculated these. Round to 3 decimal places is 0.010. I already did that one. Take a look at number 8. Number 8 says a random sample of N equals 260. They describe the population is 13 to 17-year-old teenagers. And they were asked about social media. Of those, 201 did not use social media. Find the sample proportion of teenagers who use social media. Oh, they both say do, they used. That they do use, this is did use. They didn't try to trick us. I thought they had to try to trick us. I read a not into the sentence that was not there. Isn't that fantastic? So as a reminder, P hat is X over N. And X is the number of students that, or teens that did use it, 201, and N was the number of students asked, 260. It says it wants to 3 decimal places. .773. That's all there was on that question. All right, I'm gonna give you a little while to work on the like 8.2 or chapter 8 homework if you want, or you can take a break. Either way, I'm gonna hit stop record for now.